So here I'm going to give you an opportunity to try something on your own and then see if we get the same answer. And then we'll also look at an application. So this one is already in the right form, y equals mx plus b. That's great. Remember, this is our slope. Pause the video, by the way, and do the problem if you haven't already. And that's our b. So here's our b. This is our x-axis. Oh no. I don't know what's causing this sometimes, but yeah, sometimes this program just gets a little concerned, a little stressed out. It pauses itself and doesn't let me write anymore. So there we are. That's the y-axis, that's the x-axis, and our slope is -1/2, which means down 1, right 2, down 1, right 2. When we graph our line, we know it has a negative slope, so we should expect that our line is decreasing, going down. We're going to use a solid line to connect these dots because our equation is greater than or equal to. And all that's left, well, we're bigger than this line. So we're looking at everything above this line. We'll highlight everything above. That's it. We could plug in a test point. 0, 2 would work. I love zeros. But anything over there should work. A solution to an inequality, is just something that makes the inequality true. Let's get into something a little trickier. A store sells peanuts for $4 a pound and cashews. I'm just going to write that down. All right, peanuts are $4 per pound. That's not how you write $4. The dollar sign goes first. $4 per pound. Cashews is $8 per pound. Plans to sell a new mixed nut blend in a jar. What combination of peanuts and cashews are possible if they want the mix to be less than or equal to $6? And graph your answer. So whenever we have an application problem, if you don't know what variables you should use, look at what they're asking you to do. What combination of peanuts and cashews? That tells you the variables. What combinations of peanuts and cashews tells us the variables. Let P be the amount of peanuts. And what are our units going to be here? We want to know how many peanuts we're putting. Let's not count the peanuts. That would be silly. Let's say it's how many pounds of peanuts. And then C be the amount of cashews. Again, also in pounds. I'm using the squiggles to just not write the thing that's right above it. Well, then what are our requirements? Well, we want the mix to cost $6 or less. So one of our requirements, wait, I think we only have one requirement here. I'm getting ahead of myself. We're going to get into systems after this, and then we'll have 2 equations or 2 inequalities. We just want the mix to cost $6 or less. We want the cost to be less than or equal to $6. So what is the cost? Well, peanuts are going to be $4 for every pound. So if there was 1 pound of peanuts, it'd be $4. 2 pounds of peanuts would be $8. 3 pounds of peanuts would be $12. So the cost for peanuts is just going to be $4 for every pound of peanut we use. Similarly, right, cashews are costing us $8 for every pound of cashews we use. So that's the cost, and that needs to be less than or equal to 6. Now we can graph this. We don't have y's and x's anymore. You could have called these y and x. And it doesn't matter which one you have as the input and which one you have as the output. Let's do, I don't know, P and C. It's actually a little easier if we flip it, but it doesn't really matter. So if P is our output, let's solve for P. We solve for P, it's going to make it easier to graph. Just like solving for Y. We usually solve for our output. So to do that, right, we subtract 8C from both sides. That's going to give us that 4P is less than or equal to 6 minus 8c. Divide everything by 4. Divide both sides by 4. So P is less than or equal to 6 divided by 4 is 3/2. Minus 8 divided by 4 is 2. Okay. So our intercept is 1.5. We're getting a little squished here. Let's have this be 1. This is 2. This is 3. Okay. Have this be 1. This be 2. This be 3. I want to make things a little easier to graph. Okay, so let's see. The peanuts, that's 3/2 minus 2c. We start at 1.5. We go down 3, right 2. Okay, so down 1, 2, 3, and right 1, 2. Okay, so this would be another point on the line. This would be another point on the line. So in this case, you have to be very careful when you scale your axes. In this case, down 3 units and right 2 units is the same as down 3 boxes and right 2 boxes, but that's not always the case. Okay, so if your X and Y are scaled the same, it will always be the case. But if your X and Y are scaled differently, it won't always be the case. So watch out for that. And we'll graph this line with a solid line because we have a less than or equal to sign. And we're getting a little ahead of ourselves here. It says what combinations are possible. So this is what it's going to be. But in reality, really, we're kind of getting ahead of ourselves because we're also going to say that this is true, right? We're not going to have negative pounds of peanuts. We're not going to have negative pounds of cashews. So we're really stuck in the first quadrant, right? What this means right here, this just means first quadrant. Input has to be positive or 0, and output has to be positive or 0. So when you highlight our answer, it really is just right here. It's under the line because P is less than or equal to. Okay, and then we're only looking at the things in the first quadrant because we're not going to have negative quantities here. Also, I failed kindergarten. I can't color within the lines, but I won't judge you if you won't judge me for that. All right, there's our solution. If you shaded it on your own, you could shade something that looks like this, etc. Okay. And that's pretty much it. Let me know if you have any questions and have a good rest of your day. Woo!